Welcome to VINDAL'S concept. We are going to be going into projectile motion, and this is question 2 on the series. And the question reads, a body is projected from the ground at an angle theta to the horizontal with a velocity of 30 meters per second. It reached a maximum height of 11.25 meters. Now the question says, calculate the value of the theta, the time taken to strike the ground, the range, its velocity, 2 seconds after projection. All right, we are going to start by making a sketch of this question. Let's assume this is the straight line, and this is, let me call this one the initial vertical component. Let me say Vy, and this place Vx. Now, the body, this is the point of projection, which is the origin, and the body was projected this way, and the body hits this ground. Then, with an initial or velocity which is given as 30 meters per second at an angle unknown. So our intention is to get this angle. What I want you to understand is, first, there is something we call vertical component. This Vy is given as the vertical component of the velocity. And this initial vertical component of this velocity is given as V, let me say Uy, initial vertical component is given as U sine theta. That is initial vertical component. And it changes with time, but this one is at t equal to 0. What do I mean by t equal to 0? At this origin where it is 0, the time at that point when t is 0, this vertical component of the speed is given as u sine theta. But at every other time, Vy, which is the vertical component, is given as u sine theta minus gt. This time, as it is changing, this value will also going to be changing, which is called the vertical component of this speed. However, we have a horizontal component of the velocity, which is given as u cos theta, and this value is constant throughout the trajectory or the movement of the body in the air. Point I want you to take cognizance of before we go further in solving this question. However, what our intention is to find the value of theta, but they have given us the maximum height. Now that we have the maximum height, how then do we find the theta? So what I'm going to do is to say that h max, which is given as the maximum height, is given as u square sine square theta all over 2g. Now, because I do not know, let me show you. Remember, this angle, this theta, is what I don't know, and I'm looking for it. However, this maximum height is already given to me as 11.25. That's the maximum height. Then u is already given to me as 30 meters per second. So I'm going to write 30 So this is going to be 30 squared times, this is sine, I don't know the angle, so this is going to be square theta all over 2 times g, as resistance due to gravity is given as 10. All right. Okay, so let's take off the upper part of this. Okay, so all right, let's take it off from the top. So what I'm going to do is to do that. All right, so I'm going to have 11.25 is equal to 30 times 30 is going to be 900. Then sine square theta all over 20. Now, 2 cancels this, and this into this is 45. So I'm going to have 11.25 is equal to, this is 45 sine square theta. So let me take down all the ones I've written below. All right, let me also use a dark pen, my black pen. Okay, so this is 11.25 divided by 45 is equal to sine square theta. Now, 11.25 divided by 45 is 0.25. So this is going to be 0.25 is equal to sine square theta. Now, this is a, a power of 2. To remove it, I'm going to take the square root of both sides. So this will cancel the 2 there. So square root of 0.25 is going to be 0.5. Square root of 0.25. This is going to be 0.5, which is equal to sine theta. Because the 2 has gone out with the roots. So we now have this. Therefore, theta is equal to sine inverse of 0.5. Then, then the theta there is going to be 30 degrees. Okay, so this theta, we have gotten this theta to be 30 degrees. So this is going to be 30 degrees. All right, so let's go to solving the second one, the range of the equation. Okay, to find the time taken to strike the ground. The time taken to strike the ground is given as time of flight, and the time of flight is something as 2 sine theta all over g. This is the time of flight. Therefore, the time of flight is going to be 2 times 30 sine. The angle is given as 30 degrees all over 10. So this cancels this. So t, time of flight, is going to be, and this is going to be 6 sine 30, which is going to be 3. Yes, because sine 30 is 0.5. 6 times 0.5 is going to be 3 seconds. All right. So this is called the time of flight, which is the time taken to strike the ground. All right. So let's go to the next one, which is the range. The third one is the range. So this one is something as 3 seconds. So let's go to the range. The range is given as u square sine u square sine u square sine 2 theta all over g. All right. Therefore, I'm going to say that r is going to be, u is 30, so this is 30 degree sine 2 times the angle there is 30 all over g is 10. So r is given as, oh sorry, this is 30 square, not 30 degree. So this is going to be 900 sine 60 all over 10. This 0 cancels this 0. So have that r is 90 sine 60 degrees. So 90 sine 60 is given as, so the range is given as 7.94 meters. The range is the distance from the point of projection to the point where the body hits the projectile propellant. So this is going to be 77.94 meters. All right. The last question here, this is 77.94 meters. So the last question here is saying its velocity after projection. I mean its velocity 2 seconds after projection. So how do we solve that? All right. I am going to explain this concept by drawing it. Let's assume that so as the body has moved, this is the maximum height, and this is going to be 1.5 seconds. And then at this point, Vy is 0. Then at somewhere here, and this is going to be 2 seconds. Now at 2 seconds, what happens? What happened is that there is a vertical component of the velocity which is given as Vy, and there is a horizontal component of the velocity which is given as Vx. And then there is this, I will call it the resultant or the speed u after the 2 seconds. Now the question did not say I should find the Vy, which is the vertical component of the speed. The question did not say I should find the Vx, which is the horizontal component of the speed. The question said I should find u, which is the resultant. And our idea of vectors is always saying that u, which is the resultant vector, is given as Vy square plus Vx square. And this leads us to what I said in the beginning part of this solution, where I said that Vy is given as u sine theta minus gt, where at this point, this is the vertical component of a projectile is changing at every point with respect to this time, and the time at this case is 2 seconds. So I'm going to say Vy is given as u is 30 sine 30 minus 10 times 2. So this is going to be, and this is the same thing as saying that Vy is equal to 30 sine 30 is going to be 15 minus 10. So Vy is going to be 5 seconds. And remember, this is actually 20, and this is going to be minus 5 seconds. No, that shouldn't be seconds. This is meters per second. All right, so I've gotten my Vy. So this is my Vy is going to be minus 5 meters per second. So I'm going to look for my, I'm going to look for the horizontal component of the speed. So the horizontal component is a constant value throughout. It is given as u cos theta. So this is Vx, which is going to be equal to 30 cos 30, and that is going to be 25.98 meters per second. Now here comes the speed after 2 seconds. the speed as after 2 seconds is given as the square root of Vy squared plus Vx squared. That is V sub y and V sub x. So this is u after 2 seconds is given as square root of minus 5 squared plus 25.98 squared, and the value is going to be, and this is going to be 25 plus, and this is going to be 675 all squared, and this is going to be, square root of 25 plus 675 is 700, and u after 2 seconds is given as 26.45 46 meters per second. That is the answer for this value. Thank you for being part of this class. Remember to always subscribe, come back to this channel, like and comment, and also share the video. Thank you.